March 1943. A forward maintenance depot, 15 kilometers southwest of Tunis, Tunisia. The captured American vehicle sat in the desert sun, its white star still visible beneath hastily applied German crosses. Oberfeld webel Karl Richter, chief mechanic of the reconnaissance battalion's motorpool, approached the Willys MB with his toolbox and a skepticism born from years maintaining Wehrmacht vehicles in North Africa's punishing conditions. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. This single captured American Jeep, serial number 114739, built by Willys-Overland and belonging to the 2nd Armoured Division's Reconnaissance Company, would trigger a crisis of confidence among German mechanics that would echo through Wehrmacht maintenance depots for the rest of the war. The engineering philosophy of modern warfare was about to be rewritten, not through superior firepower or advanced technology, but through something the Germans had never prioritized: automotive simplicity that simply refused to need repair. Richter had spent the morning examining the vehicle's exterior, photographing damage from the firefight that had forced its American crew to abandon it near Kasserine Pass. 2 bullet holes in the hood, a cracked headlight lens, minor scrapes along the fenders. Nothing catastrophic, nothing that should prevent a thorough mechanical inspection. He opened the hood expecting complexity. What he found instead was space. The Continental R975 radial engine sat almost casually in the engine compartment, surrounded by generous clearances that would make any mechanic's work easier. German vehicles packed components tightly, maximizing performance within constrained spaces, requiring specialized tools and contortionist flexibility for simple maintenance tasks. This American engine could be accessed from any angle. A mechanic could reach every bolt, every connection, every adjustment point without removing surrounding components. Richter pulled his standard Wehrmacht toolkit from the truck, 17 specialized tools, each precision machined for specific Wehrmacht vehicle applications. Most German military vehicles required at least a dozen tools for routine maintenance. The Kübelwagen, Germany's answer to the American Jeep, demanded specialized wrenches for its air-cooled engine, specific tools for its reduction gearing, and careful attention from trained mechanics who understood its sophisticated engineering. He selected a standard wrench and tested it on the Jeep's engine mount bolts. They loosened smoothly. He tried another fitting. Standard threading, another, also standard. Every fastener on this American vehicle appeared to use common sizes that could be serviced with basic tools. No specialty fasteners, no precision instruments required. The spark plugs drew his attention next. In German vehicles, accessing spark plugs often meant removing engine covers, disconnecting fuel lines, and creating space for specialized sockets. The Jeep's spark plugs sat exposed and accessible. A mechanic could change all 4 in minutes with one simple wrench. The simplicity seemed almost insulting to German engineering pride. Richter moved to the transmission, expecting the complexity that characterized German drivetrains. The Wehrmacht's Kübelwagen used an air-cooled engine and clever reduction gearing that required understanding portal axles and specialized maintenance procedures. Panzer transmission systems demanded double-clutching techniques and careful throttle management to avoid damage. The Jeep's transmission sat beneath a simple access plate, 4 bolts. Remove the plate, and every internal component became visible and accessible. The gear synchronization system, German intelligence reports had mentioned this feature, eliminated the need for double-clutching. Any soldier with basic automotive knowledge could drive this vehicle without specialized training. The oil dipstick caught his eye. It protruded from the engine block at chest height, easily visible, clearly marked. Checking oil required no special procedure, no careful measurement, no reference to technical manuals. Pull the dipstick, read the level, add oil if necessary. German vehicles often buried dipsticks deep in engine compartments, requiring mechanics to feel for them while kneeling in sand or mud. An American supply document had been left in the vehicle. Richter examined it carefully, his limited English sufficient to understand the contents. A list of spare parts recommended for field maintenance: spark plugs, oil filter, fan belt, carburetor gasket, brake shoes, basic components, nothing exotic, nothing that required factory precision or specialized manufacturing. The document listed part numbers with a curious notation, interchangeable MB/GPW. Richter knew from intelligence briefings that Ford Motor Company also manufactured American Jeeps, designated GPW. This notation suggested something extraordinary. Parts manufactured by completely different companies, in different factories, could be installed interchangeably, without modification or fitting. German military vehicles came from multiple manufacturers, but achieving true parts interchangeability remained theoretical. A Kübelwagen from the Wolfsburg factory might use slightly different specifications than one from another production facility. Mechanics learned to file parts, adjust clearances, and carefully fit components that should have been standardized but varied enough to cause problems. The concept of genuine interchangeability, where a Ford-built component would fit perfectly into a Willys-built vehicle without any adjustment, represented an engineering philosophy Germany had never achieved despite years of standardization efforts. Richter called over Gefreiter Hans Müller, his assistant mechanic, a 22-year-old from Stuttgart who had worked in his family's automotive repair shop before conscription. "Look at this engine compartment," Richter said in German. "What do you see?" Müller studied the Jeep for several moments. "Space, Herr Oberfeld webel. Too much space. It's inefficient. Or perhaps it's intentionally simple," Richter replied. "Notice the accessibility. A conscript with 3 weeks training could maintain this vehicle. Our Kübelwagens require trained specialists." He handed Müller a standard wrench. "Remove the valve cover." Müller hesitated. German engines used multiple bolt types, required specific torque specifications, and demanded careful procedures to avoid damage. He positioned the wrench carefully, expecting resistance or complications. The valve cover came off in 30 seconds. 6 bolts, all identical, all easily accessible. The valve train sat exposed, clearly visible, with adjustment points marked directly on the components. No reference to technical manuals required. No specialized knowledge necessary. "Amerikanische Einfachheit," Müller whispered. "American simplicity." Richter had been examining Wehrmacht vehicles for 8 years, since 1935 when the new military began its motorization programs. He had maintained Kübelwagens across France, Greece, and North Africa. He understood the sophisticated engineering that German designers valued, portal axles that provided ground clearance through clever gearing rather than suspension height, air-cooled engines that eliminated radiators and cooling systems, lightweight construction that allowed 4 soldiers to manhandle vehicles out of mud or sand. All of these features represented intelligent engineering solutions. They worked, but they worked only when maintained by skilled mechanics with proper tools and adequate spare parts. And in North Africa, by March 1943, skilled mechanics, proper tools, and adequate spare parts had all become scarce commodities. The Jeep represented a different philosophy entirely. American engineers had not designed for sophistication. They had designed for sustainability, for continuous operation by minimally trained personnel using basic tools with universally available spare parts. The engineering elegance lay not in clever solutions to difficult problems, but in avoiding difficult problems through straightforward design. Richter spent the afternoon documenting every accessible component: the fuel pump, mounted externally, easily visible, removable with 2 bolts. German fuel pumps often required partial engine disassembly to access. The oil filter, a simple screw-on canister that could be changed in less than 5 minutes. German vehicles used internal filtration systems requiring careful disassembly and cleaning. The electrical system particularly impressed him. 6-volt architecture, identical to German vehicles, but with generous wire gauges and clearly marked connections. A colored wiring harness made circuit identification simple even for inexperienced mechanics. German vehicles used black wiring throughout, requiring careful tracing and reference to electrical diagrams for troubleshooting. The Jeep included a backup generator that could power the turret traverse even when the main engine stopped. Richter read this in the technical manual found in the glove box. The concept seemed extravagant. Why include redundant systems that added weight and complexity? But he immediately understood the tactical value. German vehicle electrical systems, when they failed completely. American systems included backups that kept critical functions operational even during component failures. As sunset approached, Richter compiled his initial assessment. The captured Jeep would be ready for German service within 24 hours. The bullet damage required no specialized repair. Standard body shop techniques would patch the hood. The broken headlight could be replaced with a German equivalent or simply removed, given the Jeep's tactical headlights provided adequate illumination. Mechanically, the vehicle required only routine maintenance, oil change, filter replacement, general lubrication, tasks that Müller could complete without supervision, tasks that any minimally trained soldier could perform following simple instructions. He drafted his report for the battalion commander that evening, choosing words carefully. German military reports required objective assessment, but Richter could not suppress his professional admiration for what American engineers had achieved. The captured American reconnaissance vehicle Willys MB represents engineering philosophy fundamentally different from Wehrmacht standards. The vehicle prioritizes accessibility, maintainability, and operational simplicity over performance optimization. All major components can be serviced using standard tools without specialized equipment. Repair procedures require minimal technical expertise. Parts standardization appears absolute, with interchangeability between multiple manufacturers documented in vehicle manuals. Assessment. The American vehicle design achieves sustained operational readiness through engineering simplicity rather than technical sophistication. Maintenance requirements are minimal. Training requirements are minimal. The vehicle can be maintained and operated by personnel without specialized automotive knowledge. Recommendation. Vehicle is suitable for immediate Wehrmacht service pending minor cosmetic repairs. Request technical intelligence examination to document American engineering methods for potential application to Wehrmacht vehicle programs. The report circulated through command channels over the following weeks. It reached Afrika Korps headquarters in late March. By April, copies had been forwarded to Wehrmacht automotive procurement offices in Berlin. Richter's observations, combined with similar reports from other mechanics examining captured American vehicles, began raising uncomfortable questions about German engineering priorities. April 1943. A technical conference room, Wehrmacht High Command, Berlin. Oberst Friedrich Hoffmann, chief of the Army Weapons Office Automotive Section, reviewed captured vehicle assessments from North Africa, Sicily, and the Eastern Front. The pattern was undeniable and deeply troubling. American vehicles required significantly less maintenance than comparable German equipment. American vehicles could be repaired using basic tools and minimal expertise. American vehicles featured parts standardization that actually functioned as intended rather than remaining theoretical. And American vehicles continued operating under conditions that disabled German equipment. The Kübelwagen had served adequately throughout the war's early years. Based on the Volkswagen Beetle, designed by Ferdinand Porsche, it represented clever engineering that achieved reasonable off-road performance without four-wheel drive. The air-cooled engine eliminated cooling system vulnerabilities. The lightweight, approximately 725 kilograms empty, meant soldiers could push vehicles out of difficulty. The flat underbody helped vehicles slide over obstacles rather than becoming stuck. But the Kübelwagen achieved these advantages through complexity that required skilled maintenance. The air-cooled engine demanded careful attention to cooling fin cleanliness. The reduction gearing in the rear portal axles required specific lubricants and regular inspection. The rear-wheel drive configuration, adequate on European roads, proved marginal in North African sand or Russian mud. Most critically, the Kübelwagen relied on German production capacity and supply systems that were degrading rapidly by 1943. Spare parts became scarce. Qualified mechanics were conscripted as infantry replacements. The sophisticated engineering that had seemed advantageous when Germany controlled most of Europe became a liability when fighting a global war against enemies with superior industrial capacity. The American Jeep succeeded not through sophistication but through opposite principles. Generous engineering margins meant components rarely operated at maximum stress. Straightforward maintenance procedures meant any soldier could keep vehicles running. Universal parts standardization meant field repairs used components from any supply depot or any damaged vehicle. Hoffman had studied American automotive industry before the war. He understood that the United States had developed mass production techniques through decades of civilian automobile manufacturing. Henry Ford's assembly line methods, General Motors' multiple brand strategy, Chrysler's integration of diverse technologies. These companies had learned to manufacture hundreds of thousands of vehicles annually, training workers quickly, maintaining quality through process standardization rather than craftsman skill, creating supply chains that functioned despite enormous scale. The Jeep represented this mature industrial philosophy applied to military requirements. Willys-Overland and Ford Motor Company built Jeeps using automotive industry methods they had refined over 20 years. They designed for mass production. They designed for field maintainability. They designed assuming operators would have minimal training and mechanics would have basic tools. Germany had never developed equivalent automotive industry maturity. Before the war, automobile ownership remained limited to wealthy Germans and party officials. The Volkswagen program, announced by Hitler in 1934, had promised to deliver affordable cars to German workers. By 1939, fewer than 1,000 civilian Volkswagens had been produced. This vast difference in automotive experience translated directly into military vehicle design philosophy. Americans built vehicles that mechanics with civilian automotive training could maintain. Germans built vehicles that required specialist training and constant expert attention. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The technical assessment expanded through spring and summer of 1943 as more captured Jeeps reached Wehrmacht maintenance facilities. Each examination revealed additional evidence that American engineering had solved problems German designers hadn't recognized existed. May 1943. Mechanized Workshop Depot, Palermo, Sicily. Hauptmann Ernst Weber supervised the most comprehensive examination yet of American Jeep engineering. 3 captured vehicles sat in the workshop bay, each at different stages of disassembly. Weber had assembled a team of 6 mechanics, all former civilian automotive professionals, all experienced with Wehrmacht vehicle maintenance. The assignment was specific. Document every aspect of American Jeep construction that differed from German engineering standards. Identify maintenance advantages. Assess field repair capabilities. Determine what made these vehicles so remarkably reliable under conditions that destroyed German equipment. Weber began with the most fundamental question. How did American engineers achieve four-wheel drive without the complexity that plagued German attempts at similar systems? Germany had experimented with four-wheel drive light vehicles throughout the 1930s. The Einheits PKW program, the Standardized Military Vehicle Initiative, had produced various four-wheel drive cars between 1933 and 1938. These vehicles featured sophisticated systems, including four-wheel steering in some variants. They were engineering marvels. They were also expensive to produce, complex to maintain, and ultimately rejected by 90% of Wehrmacht branches as unfit for wartime service. The American Jeep's four-wheel drive system, by contrast, seemed almost primitive in its simplicity. 2 floor-mounted levers controlled everything. One lever engaged the transfer case, directing power to the front axle. Another lever selected high or low range in the transfer case. No complicated linkages. No precision adjustments. A soldier could engage four-wheel drive while moving simply by pulling a lever. Feld-Webel Otto Schneider, the team's drivetrain specialist, spent 2 days studying the transfer case. He removed it completely from one vehicle, disassembled it on a clean workbench, photographed every component, and measured critical dimensions. Herr Hauptmann, this is remarkable, Schneider reported. The transfer case uses straight-cut gears, basic roller bearings, and simple dog clutches for engagement. Nothing sophisticated. but the tolerances are generous. Components are overbuilt. The design accepts imprecise engagement without damage. Weber understood the implication immediately. German transfer cases required precise synchronization. Operators learned specific techniques to avoid grinding gears or damaging clutches. The training emphasized skill development because the equipment demanded skill. The American system required no skill because the design accommodated operator error through generous engineering margins. "What about maintenance?" Weber asked. 4 bolts secure the transfer case to the transmission. Standard wrench sizes. The unit can be removed and replaced as a complete assembly in under 30 minutes. Internal maintenance requires draining oil, removing 6 cover bolts, and accessing all components without special tools. Schneider paused, choosing his words carefully. Herr Hauptmann, a conscript with 1 week of training, could rebuild this transfer case. Our systems require factory-trained specialists. The electrical system revealed similar philosophy. Gefreiter Karl Richter, no relation to Oberfeld webel Karl Richter in Tunisia, specialized in vehicle electrical systems. He had worked for Bosch before conscription, understanding both civilian and military electrical engineering. The Americans use color-coded wiring, Richter explained, pointing to the exposed harness in the disassembled Jeep. Red for battery positive, black for ground, green for lighting circuits, yellow for ignition systems. A mechanic can trace any circuit visually without reference to diagrams. German vehicles used black wiring throughout. Proper troubleshooting required electrical diagrams, careful measurement with testing equipment, and systematic elimination of possibilities. American troubleshooting meant following colored wires from component to component until the problem revealed itself. The wire gauge is generous, Richter continued. American engineers used heavier wire than necessary for the current load. This provides safety margin against voltage drop, reduces heat generation, and makes the system more resistant to battle damage. A partially severed wire might still conduct sufficient current to maintain function, he demonstrated by cutting halfway through an ignition wire. The engine continued running. German vehicles, with thinner wiring calculated precisely for expected loads, would have failed immediately. The brake system particularly impressed Weber. Wehrmacht vehicles used mechanical brakes, requiring frequent adjustment to maintain proper function. Cables stretched, linkages wore. Mechanics spent significant time adjusting brake systems to compensate for wear and maintain balanced braking. The Jeep used hydraulic brakes. Feldwebel Heinrich Koch, the team's brake specialist, examined the system with professional fascination. Hydraulic fluid transmits force equally to all 4 wheels automatically, Koch explained. No cables to stretch, no linkages to wear, no adjustment required except replacing brake shoes when worn. The system self-adjusts through hydraulic pressure. Maintenance requirements? Weber asked. Check fluid level monthly. Replace brake shoes when worn, approximately every 10,000 kilometers under normal conditions. Bleed air from lines if system is opened. That's the complete maintenance schedule. Koch pulled out his notes on Kugelwagen brake. Maintenance. Our mechanical systems require adjustment every 500 kilometers. Replacement of cables and linkages every 3,000 kilometers. Constant attention to maintain proper function. The engine examination provided the most comprehensive comparison. Oberfeld webel Franz Dietrich had maintained Wehrmacht vehicles since 1936. He understood German engineering philosophy intimately. The captured Jeep engine confused him initially because it violated every principle he had learned. The Continental R975 radial engine displaced 134 cubic inches and produced 60 horsepower at 4,000 revolutions per minute. German engineers would have extracted more power from that displacement. The compression ratio seemed conservative. The carburetor was simple. The valve train used pushrods rather than overhead camshafts. This engine makes no attempt at performance optimization, Dietrich reported. The Americans designed for reliability and ease of maintenance rather than maximum power output. He pointed to specific features. The valve clearances are generous. Precise adjustment is unnecessary. The engine will run acceptably with clearances anywhere within a wide range. German engines require precise valve adjustment to function properly. The cooling system is simple but effective. Large radiator capacity, heavy-duty water pump, thermostat that regulates temperature automatically. The system handles extreme conditions without requiring careful monitoring or frequent maintenance. The oil filtration uses a replaceable element. Screw off the old filter, screw on a new one. 5 minutes. German engines use internal oil passages requiring careful cleaning during maintenance. Dietrich had spent 20 years working with automotive engines. He recognized quality engineering when he saw it, even when that engineering violated German design principles. The American engine represented mature understanding of what soldiers needed in combat. Reliability, simplicity, maintainability. The Americans had sacrificed theoretical performance for practical sustainability. The toolkit comparison crystallized the philosophical difference. Each Jeep came with a standard toolkit stored in brackets welded to the vehicle body. Weber inventoried the contents carefully. 1 adjustable wrench, 1 combination wrench set covering all fastener sizes on the vehicle, 1 screwdriver, 1 pair of pliers, 1 spark plug wrench, 1 tire pressure gauge. Basic tools, nothing specialized. Everything necessary for field maintenance and emergency repairs. The Wehrmacht Kübelwagen toolkit contained 17 specialized tools, specific wrenches for engine adjustments, specialized drivers for portal axle maintenance, precision instruments for carburetor adjustment, tools designed for trained mechanics, not for average soldiers. June 1943. Forward Maintenance Depot, Southern Italy. Oberfeld webel Peter Kaufmann commanded a motorpool supporting a reconnaissance battalion. His unit operated a mixed fleet of Kübelwagens, captured Italian vehicles, and 3 American jeeps captured during the Sicily fighting. Kaufmann maintained detailed maintenance logs for every vehicle. The data revealed patterns that troubled him deeply. Over 3 months of operation, his 12 Kübelwagens had required 117 maintenance interventions, carburetor adjustments, valve clearance adjustments, brake cable replacements, portal axle inspections, electrical troubleshooting. Each intervention took mechanics away from other duties. Each required parts from increasingly unreliable supply chains. The 3 captured jeeps had required 19 maintenance interventions during the same period. Oil changes, filter replacements, 1 brake shoe replacement, routine services that any soldier could perform following simple instructions in the technical manual. The operational readiness statistics were even more stark. His Kübelwagens averaged 72% operational availability. On any given day, roughly 1/3 of his German vehicles were deadlined, awaiting parts or repairs. The 3 captured jeeps maintained 100% operational availability throughout the 3-month period. Kaufmann drafted a report for his battalion commander that he knew would cause discomfort at higher headquarters. But the data was undeniable, and lying about equipment performance served no one's interests. American reconnaissance vehicles demonstrate superior operational reliability compared to Wehrmacht equivalents. Contributing factors include simplified maintenance requirements, reducing mechanic workload by approximately 70% compared to German vehicles, parts availability through captured American supply stocks and field salvage from destroyed vehicles, design tolerances that accommodate wear without performance degradation, maintenance procedures executable by minimally trained personnel without specialized tools or expertise. Recommendation: captured American vehicles should receive priority allocation to units requiring maximum operational readiness. Wehrmacht reconnaissance units currently experience significant capability gaps due to German vehicle unreliability. Similar reports accumulated through summer 1943 from Wehrmacht maintenance facilities. Across all theaters, the pattern was consistent. American vehicles worked better, they broke less frequently. When they did require maintenance, that maintenance was simpler, faster, and required fewer specialized resources. July 1943. Army Weapons Office, Berlin. Oberst Hoffmann convened a conference of senior automotive engineers to address the growing evidence of American engineering superiority. 12 men attended, representing Wehrmacht procurement, vehicle manufacturers, and field maintenance commands. The discussion began diplomatically but deteriorated rapidly into uncomfortable acknowledgement of German limitations. "The Americans build vehicles that soldiers can maintain," stated Major Hans Kruger from Field Maintenance Command. "We build vehicles that require mechanics. In 1939, when we had mechanics, this worked adequately. In 1943, when mechanics are conscripted as infantry replacements, we cannot maintain our vehicle fleet." "The issue is not just mechanics," countered Dr. Wilhelm Schmidt from Volkswagen. "American vehicles reflect decades of civilian automotive industry maturity. They design for mass production. They design for unskilled labor. They design assuming operators will abuse equipment. German engineering has never operated under these constraints." "Perhaps German engineering should have operated under these constraints," Hoffmann replied quietly. "We are losing the war of maintenance. American units maintain higher operational readiness with less skilled personnel and simpler supply chains. This advantage matters more than any tactical performance superiority our vehicles might possess." He distributed copies of field reports documenting comparative reliability. The data was crushing. Across all theaters, American vehicles maintained operational readiness rates 20 to 30 percentage points higher than comparable German equipment. "Gentlemen, we must face reality," Hoffmann continued. "American automotive engineering philosophy is superior for sustained military operations. They have solved the problem of keeping vehicles operational under field conditions with minimally trained personnel and limited supply chains. We have not solved this problem. We did not recognize it was a problem that needed solving." The meeting concluded without resolution. Germany's automotive production capacity was already strained to its limits. Allied bombing campaigns targeted key manufacturing facilities. Raw materials grew increasingly scarce. Qualified workers were diverted infantry units to replace casualties. The Wehrmacht could not retool its entire vehicle production system in the middle of a losing war. But the acknowledgement of American superiority marked a turning point in German technical assessment. The dismissive attitudes of 1941 and 1942 had evaporated. German mechanics and engineers now recognized that American simplicity represented sophisticated understanding of what military operations actually required. August 1943. Kasserine Pass region, Tunisia. Oberfeld webel Karl Richter, the mechanic who had examined the first captured Jeep in March, received orders to prepare captured American vehicles for German reconnaissance operations. His battalion commander had seen Richter's earlier assessment and wanted American vehicles prioritized for the most critical missions. Richter selected 3 Jeeps from the collected captured vehicles. He supervised complete maintenance on each one, documenting procedures and training junior mechanics in American vehicle servicing. The maintenance took 2 days per vehicle: oil change, filter replacement, spark plug inspection and replacement, brake adjustment, tire pressure check, general lubrication. Straightforward procedures requiring no specialized knowledge. For comparison, similar maintenance on a Kübelwagen typically required 3 days and specialized tools that were increasingly difficult to obtain from supply channels. The Kübelwagen's air-cooled engine demanded careful attention to cooling fin cleanliness. The portal axles required specific lubricants. The electrical system needed systematic troubleshooting to address the chronic problems that plagued German military electrical components. Richter included American Jeeps in his regular maintenance rotation for the next 4 months. The experience reinforced his earlier assessment. These vehicles simply worked with minimal intervention. Soldiers operated them roughly, subjected them to punishing conditions, and used them far beyond their rated capacity. They continued functioning. His maintenance logs recorded the pattern clearly. German Kübelwagens average 140 maintenance hours per vehicle per month, 7 to 9 deadlined days per month awaiting parts or repairs. American Jeeps average 30 maintenance hours per vehicle per month, 0 deadlined days during 4-month observation period. The implications extended beyond simple reliability statistics. When vehicles consistently worked, units could plan operations, knowing their transportation would be available. Commanders could commit to missions without calculating probability of mechanical failure. Soldiers could focus on tactical concerns, rather than worrying whether their vehicles would reach the objective. German reconnaissance units operating Kübelwagons learned to plan conservatively, assuming that 1/3 of their vehicles would be unavailable on any given day. American units operating jeeps planned operations based on full vehicle availability because that availability was reliable. This operational flexibility advantage multiplied across an entire army. American divisions maintained mobility that German divisions could only achieve intermittently. The cumulative effect of thousands of reliable vehicles versus thousands of unreliable vehicles shaped campaign outcomes as surely as tactical brilliance or strategic planning. September 1943. Wehrmacht Technical Intelligence Facility, outside Berlin. The most comprehensive technical examination of captured American vehicles began under direction of the Army Weapons Office. 12 jeeps, captured across various theaters, underwent systematic testing designed to quantify every aspect of their engineering. Engineers measured maintenance time requirements. They documented tool requirements. They tested components to failure to determine safety margins. They operated vehicles under extreme conditions to establish operational limits. They disassembled every system completely to understand construction techniques and material specifications. The resulting technical report, classified and distributed only to senior Wehrmacht and production officials, documented American engineering advantages with scientific rigor. Key findings included maintenance time requirements average 65% less than comparable German vehicles. Tool requirements limited to 8 basic sizes compared to 17 specialized tools for German vehicles. Component safety margins average 40% above operational requirements, providing resistance to wear and abuse. Parts interchangeability confirmed across multiple manufacturers, with tolerances maintaining function despite production variations. Training requirements for operators and mechanics significantly reduced compared to German vehicles requiring specialized knowledge. The report's conclusion acknowledged what field mechanics had recognized months earlier. American military vehicle engineering demonstrates mature understanding of sustained operational requirements. Design philosophy prioritizes maintainability, reliability, and operational simplicity over performance optimization. The resulting vehicles achieve higher operational readiness with reduced support requirements compared to German equivalents. German engineering philosophy emphasizes performance optimization and technical sophistication. This approach produces vehicles with superior theoretical capabilities that cannot be sustained under field conditions without specialized maintenance support that is increasingly unavailable. Recommendation: future German military vehicle development should incorporate American engineering principles, emphasizing operational sustainability over performance maximization. The recommendation came too late. By September 1943, Germany's strategic situation precluded major changes to vehicle production. Allied bombing campaigns intensified. Raw material shortages worsened. The Wehrmacht fought defensive campaigns on multiple fronts with shrinking resources. But the acknowledgement represented complete reversal from the dismissive German attitudes toward American engineering in 1941 and 1942. German engineers and mechanics now understood that American simplicity was not primitive. It was sophisticated application of mature automotive industry experience to military requirements. October 1943. Forward observation post, Italian front. Lieutenant Werner Schmidt commanded a reconnaissance platoon equipped with a mixed fleet of German and captured American vehicles. His unit's mission required constant movement across difficult terrain under fire, making vehicle reliability critical to survival. Schmidt kept personal notes on vehicle performance, observations that never appeared in official reports but reflected battlefield reality. The American jeeps have become our most valuable assets. When we plan reconnaissance missions deep into enemy territory, we assign jeeps because we know they will return. The Kübelwagons might perform adequately, or they might break down 50 kilometers from our lines, forcing the crew to walk back under fire. The Americans built vehicles that work. We built vehicles that should work if maintained properly by skilled mechanics using proper parts. Under combat conditions, should work means probably won't work. The American philosophy of building vehicles that work regardless of maintenance quality or operator skill proves superior in practice. Our men prefer captured jeeps not because they are more comfortable or faster or better armed. They prefer them because the vehicles are reliable. In reconnaissance operations, reliability determines whether soldiers complete their mission and return alive. Schmidt's observations, shared informally with fellow officers, reflected growing consensus throughout Wehrmacht reconnaissance units. Given choice between German and American vehicles, experienced soldiers chose American equipment despite nationalist pride and despite official preference for German technology. November 1943 brought a systematic comparison that made German engineering limitations undeniable. Weber's maintenance facility in northern Italy conducted parallel operations testing, operating German Kübelwagens and captured American jeeps through identical mission profiles over 30 days. The test parameters were simple. Each vehicle would conduct daily reconnaissance patrols, covering approximately 120 kilometers of mixed terrain. Each would be operated by average soldiers, not specialist drivers. Each would receive only maintenance that average mechanics could provide with standard tools. Results after 30 days. Kübelwagens completed an average of 19 missions each before mechanical failures forced deadlining. Total maintenance hours per vehicle, 180. 3 vehicles suffered complete failures requiring depot-level repair unavailable in field conditions. American jeeps completed all 30 missions with 0 deadlined days. Total maintenance hours per vehicle, 45. No complete failures. All maintenance consisted of routine services. The test eliminated any remaining doubt. Under identical conditions, with identical operators and maintenance support, American vehicles performed 3 times as many missions with 1/4 the maintenance requirement. Weber's final report to Army Weapons Office concluded with stark assessment. American vehicle engineering philosophy has proven superior for military operations. German emphasis on performance and sophistication cannot overcome fundamental unreliability that eliminates tactical advantages. A vehicle that reaches the battlefield operational defeats a vehicle with superior specifications that breaks down en route. The practical recognition American engineering superiority accelerated through 1944 as Germany's strategic position collapsed. Wehrmacht units across all theaters operated increasing numbers of captured American vehicles, not because they preferred enemy equipment for ideological reasons, but because captured jeeps worked better than German vehicles. January 1944. Anzio Beachhead, Italy. A German counterattack captured an American supply depot intact, yielding 14 jeeps in various conditions. Oberst Franz Becker, commanding the assault regiment, immediately assigned captured vehicles to his reconnaissance companies. Strip identification markings and apply German crosses, Becker ordered his maintenance officer. These vehicles enter service immediately. They're more reliable than our own equipment. The maintenance officer, Hauptmann Joseph Klein, had compiled statistics on vehicle readiness throughout the Italian campaign. His data showed that German reconnaissance companies maintained average operational readiness of 58%. Companies equipped with captured American jeeps maintained operational readiness exceeding 90%. The difference was simple and brutal. German vehicles broke frequently. American vehicles rarely broke. When German vehicles broke, repairs required specialized parts increasingly unavailable through disrupted supply chains. When American vehicles required maintenance, standard parts sufficed and could often be salvaged from destroyed vehicles. Klein's mechanics had learned to prioritize captured American vehicles for maintenance time allocation. A Kübelwagen requiring carburetor adjustment might consume 6 hours of mechanic time. A Jeep requiring oil change and filter replacement consumed 30 minutes. The efficiency difference compounded across an entire motorpool. By February 1944, Klein's regiment operated 23 captured jeeps alongside 38 Kübelwagens. The captured vehicles, representing 38% of the reconnaissance fleet, completed 67% of successful reconnaissance missions. The pattern was consistent and undeniable. March 1944 brought expanded documentation of the operational advantage American vehicle reliability provided. Wehrmacht units in Italy, France, and the Eastern Front all reported similar patterns. American vehicles maintained higher readiness rates, required less maintenance, and could be repaired by soldiers with minimal training. The technical intelligence reports circulating through Wehrmacht channels grew increasingly frank about German engineering deficiencies. One report from Army Group South in Russia stated bluntly, "American reconnaissance vehicles demonstrate engineering maturity that Wehrmacht vehicle programs have not achieved. The fundamental issue is design philosophy. American engineers design vehicles that function adequately under worst-case conditions with minimal maintenance. German engineers design vehicles that function excellently under optimal conditions with proper maintenance. Battlefield conditions are never optimal. Proper maintenance is increasingly impossible." April 1944, a small village northwest of Rome. Oberfeld webel Karl Richter, now supervising maintenance for an entire reconnaissance battalion, sat in his makeshift office reviewing vehicle status reports. 14 months had passed since he first examined a captured jeep in Tunisia. His battalion operated 42 vehicles total, 19 Kübelwagens, original German equipment, 23 captured American jeeps, acquired through combat operations and salvage from destroyed units. The operational readiness statistics told the story with mathematical clarity. German vehicles, 11 operational, 8 deadlined awaiting parts, 0 undergoing routine maintenance. American vehicles, 21 operational, 0 deadlined, 2 undergoing routine oil changes. Richter had spent his entire professional career maintaining German vehicles. He understood Kübelwagen engineering intimately. He could diagnose problems by sound, identify worn components by feel, and perform complex repairs with minimal tools. He took professional pride in keeping difficult vehicles operational under impossible conditions. But professional pride could not overcome mathematical reality. American vehicles simply worked better. They worked with less effort, less expertise, and fewer resources. The engineering simplicity that had seemed almost insulting in March 1943 now appeared as sophisticated understanding of what sustained military operations actually required. He drafted his final assessment that evening, a document that would reach Army Weapons Office and influence post-war German automotive engineering philosophy. After 14 months maintaining both German and American reconnaissance vehicles under combat conditions, the following conclusions are supported by operational data. American vehicles achieve reliability through engineering simplicity. Generous component specifications provide safety margins that accommodate wear and operator error. Maintenance procedures require minimal expertise and standard tools. Parts standardization enables field repairs using salvaged components from damaged vehicles. German vehicles achieve performance through engineering sophistication. Precise component specifications provide optimal efficiency under ideal conditions. Maintenance procedures require specialized expertise and precision tools. Parts variability between production batches complicates field repairs. Under combat conditions, simplicity defeats sophistication. The vehicle that works adequately with minimal maintenance proves more valuable than the vehicle that works excellently with proper maintenance that cannot be provided. Recommendation: future German military vehicle development must prioritize operational sustainability over performance. Optimization: American engineering methods should be studied and adopted where applicable. May 1944 brought the collapse of German positions in Italy as Allied forces finally broke through defensive lines. Wehrmacht units retreated northward, abandoning vehicles when fuel supplies failed or mechanical breakdowns immobilized them. The pattern of abandoned vehicles revealed the reliability gap clearly. Allied intelligence officers cataloguing abandoned German equipment noted that Kübelwagens were frequently abandoned due to mechanical failures. Captured American jeeps operating in German service were abandoned only when fuel supplies ran out or combat damage made them inoperable. The German vehicles failed mechanically. The American vehicles failed only when external circumstances made continued operation impossible. June 1944. Normandy invasion. Wehrmacht units defending France faced American forces equipped with approximately 20,000 jeeps in the initial invasion force. German reconnaissance units, struggling to maintain even minimal operational vehicle strength, watched with professional despair as American units maneuvered with mobility that German forces could no longer match. Oberst Wilhelm Richter, no relation to Karl Richter, commanded a reconnaissance battalion in Normandy. His after-action reports documented the operational disadvantage German vehicle reliability problems created. Enemy reconnaissance forces maintain constant pressure through superior vehicle availability. American units operate jeeps in numbers we cannot match even theoretically. Their vehicles maintain operational readiness that our vehicles achieve only intermittently. The enemy can plan operations, assuming full vehicle availability. We must plan operations assuming 1/3 of our vehicles will be unavailable due to mechanical problems. This mobility advantage allows enemy forces to reconnoiter our positions constantly, identify weaknesses rapidly, and concentrate forces faster than we can respond. Superior vehicle reliability creates tactical flexibility that multiplies combat effectiveness beyond simple numerical superiority. July 1944. Wehrmacht procurement offices began planning for post-war vehicle development, a planning process that assumed German military forces would continue existing after the war in some form. The planning documents incorporated lessons learned from comparing German and American engineering. The new specifications emphasized reliability over performance, maintenance, simplicity over technical sophistication, parts standardization over optimization for specific applications. The Americans had proven these principles worked. German engineering would need to adopt similar approaches if future German military forces were to achieve sustained operational effectiveness. August 1944 brought systematic documentation of the final conclusion German engineers had resisted for 3 years. A comprehensive technical report comparing German and American military vehicle engineering stated the ultimate assessment, American automotive industry maturity, developed through decades of civilian vehicle mass production, has proven superior to German precision engineering for military applications. American design philosophy accepts lower theoretical performance in exchange for higher operational reliability. This trade-off proves advantageous under battlefield conditions where maintenance support is limited and operator skill varies widely. German engineering tradition emphasizes optimization and precision. These principles produce excellent vehicles when properly maintained by skilled mechanics. Military operations do not provide conditions for proper maintenance by skilled mechanics. German engineering philosophy proves mismatched to military operational reality. The fundamental lesson: military vehicle engineering must design for sustained operation by minimally trained personnel using basic tools under adverse conditions. American engineers understood this requirement. German engineers did not. September 1944 through May 1945. The final months of the European war saw Wehrmacht forces retreating on all fronts with collapsing logistics and disintegrating maintenance support. Under these conditions, the reliability gap between German and American vehicles widened to catastrophic proportions. German vehicles broke down at accelerating rates as maintenance became impossible and parts supplies evaporated. Kübelwagons were abandoned across Europe as mechanical failures accumulated faster than field repairs could address them. The sophisticated engineering that should have provided advantages instead created vulnerabilities that could not be overcome without functional support infrastructure. Captured American jeeps continued operating until fuel supplies ran out or combat damage disabled them. German units maintaining captured American vehicles found they could keep them operational far longer than German equipment because the simplicity allowed field repairs with improvised tools and salvaged parts. The ultimate irony appeared in the final weeks of the war. German units retreating toward Germany's borders often chose to destroy their own vehicles to prevent capture, while attempting to preserve captured American jeeps for continued use. The inverted logic was practical and undeniable. American vehicles had better chance of remaining operational under catastrophic conditions than German vehicles specifically designed for military use. May 1945. Surrender. The European War ended with Wehrmacht mechanical units surrendering alongside combat formations. The vehicle parks told the story clearly. German vehicles sat deadlined with mechanical problems that would never be repaired. Captured American vehicles, operating until the moment of surrender, remained largely operational. Allied intelligence officers conducting post-war assessments noted this pattern consistently. Technical interrogations of German mechanics and engineers revealed universal recognition that American vehicle engineering had proven superior for sustained military operations. One interrogation transcript recorded the assessment of Oberst Friedrich Hoffmann, the Army Weapons Office Automotive Section Chief, who had recognized American advantages in 1943. The Americans built vehicles that worked. We built vehicles that should have worked if conditions had been favorable. Conditions are never favorable in war. The Americans understood this. We did not. They won the engineering war by designing for reality rather than theory. The lessons learned from captured Jeeps influenced post-war German engineering directly. When the Federal Republic of Germany began developing the Leopard 1 main battle tank in the 1950s, designers consciously emphasized reliability and maintainability over pure performance specifications. The Leopard 1 incorporated design philosophies learned from studying American equipment: robust powertrain with substantial design margins, easy maintenance requiring minimal specialized tools, standardized components enabling rapid field repairs, growth potential allowing future upgrades without complete redesign. The resulting tank became one of the most successful designs of the Cold War era, serving with numerous armies and remaining in production for decades. The Leopard 1 succeeded because German engineers had finally learned the lesson American automotive industry had understood for 30 years. Reliability matters more than sophistication. Maintainability determines operational effectiveness. Simplicity defeats complexity under field conditions. 1956, Stuttgart, West Germany. A conference on military vehicle development brought together engineers from German automotive companies and Wehrmacht veterans now, advising the new Bundeswehr. One presentation analyzed lessons learned from World War II vehicle operations. Karl Richter, now a senior civilian engineer for Mercedes-Benz, delivered the keynote presentation. 23 years after his life as Oberfeld webel examining captured Jeeps in Tunisia, he had become one of Germany's leading advocates for reliability-focused engineering. In March 1943, I examined my first captured American Jeep, Richter told the audience. I was confused by its simplicity. It seemed primitive compared to German engineering sophistication. I could not understand why American engineers had not optimized performance, had not minimized weight through clever reduction gearing, had not demonstrated technical prowess through complex solutions. I understand now what I did not understand then. American engineers had optimized for the correct variable. They optimized for sustained operational effectiveness under real-world conditions. They designed vehicles that soldiers could maintain, that mechanics with basic tools could repair, that would continue functioning despite operator error and inadequate maintenance. German engineers, myself included, optimized for theoretical performance under ideal conditions. We created vehicles that worked excellently when new, when properly maintained, when operated by skilled personnel. We did not design for the reality that conditions are never ideal, maintenance is never proper, and personnel are never sufficiently skilled. The Americans won the engineering war not through superior technology, but through superior understanding of what military operations actually require. This lesson must guide our future vehicle development. Reliability first, maintainability second, performance third. This priority ordering contradicts traditional German engineering values, but it produces vehicles that work when needed, which is the only metric that truly matters. The presentation received extended applause from an audience that included former Wehrmacht officers who had experienced the reliability gap firsthand. The lessons learned from captured American Jeeps had finally, definitively, transformed German military vehicle engineering philosophy. The story of the captured Jeep and German mechanics' growing recognition of American engineering superiority represents one of World War II's most complete philosophical reversals. German forces entered the war confident in their technical superiority, dismissive of American industrial capability, certain that German precision engineering would overcome enemy advantages through superior quality. By 1943, that confidence had collapsed among engineers and mechanics, who maintained vehicles daily. By 1944, even senior officers recognized that American engineering philosophy had proven superior for sustained military operations. By 1945, the conclusion was undeniable and universal. American automotive industry maturity, developed through decades of civilian vehicle mass production, had created engineering methodology superior to German precision craftsmanship for military applications. The methodology emphasized simplicity over sophistication, reliability over performance, maintainability over optimization. This American engineering philosophy meant that ordinary soldiers could maintain vehicles with basic tools, that mechanics with minimal training could perform repairs, that supply systems could stock universal parts fitting multiple vehicle types, that operational readiness remained high despite challenging conditions and limited support. German engineering philosophy meant that vehicles required skilled specialists for maintenance, that repairs demanded precision tools and specialized knowledge, that supply systems struggled to stock diverse parts for vehicles with limited interchangeability, that operational readiness declined rapidly under field conditions when ideal support became impossible. Under combat conditions, the American approach proved decisively superior. The mathematical reality was simple and brutal. Vehicles that worked adequately with minimal maintenance defeated vehicles that worked excellently with proper maintenance that could not be provided. The captured Jeep that Oberfeld webel Karl Richter examined in Tunisia during March 1943 represented this American engineering philosophy in physical form. Every accessible component demonstrated design choices, prioritizing field maintainability. Every generous tolerance showed understanding that soldiers would abuse equipment. Every standardized fastener proved commitment to repairability with basic tools. Richter had approached that examination expecting to find inferior engineering. What he found instead was engineering matured through decades of civilian automotive industry experience that German designers had never developed. Engineering that understood military operations demanded vehicles that continued functioning despite inadequate maintenance, untrained operators, and impossible conditions. That single captured vehicle, thoroughly examined by skilled German mechanics, revealed truths about engineering philosophy that would reshape post-war German automotive development. American simplicity was not primitive, it was sophisticated application of mature understanding. German sophistication was not superior, it was mismatched to military operational reality. The lesson echoed beyond automotive engineering into broader understanding of technological development. Optimal solutions must account for real-world operational conditions. Design philosophy matters more than individual component quality. Sustainability defeats performance when operating conditions make performance irrelevant. 70 years later, the Willys MB and Ford GPW Jeeps remain icons of American industrial achievement. Over 640,000 were produced during the war years. They served on every front, in every climate, under every conceivable condition. They kept working when sophisticated equipment failed. German generals, in post-war interrogations and memoirs, consistently ranked the Jeep among the most impressive American equipment, not the most powerful, not the most advanced, but the most effective at enabling sustained operations through simple reliability. The mathematics were clear and undeniable when examined objectively. A Jeep with a 75mm gun that reliably reached the battlefield proved infinitely more valuable than a Kübelwagen with superior specifications that broke down before engaging the enemy. A reconnaissance company with 90% vehicle availability could execute missions that a company with 50% availability simply could not attempt. Reliability was not just a convenience factor or secondary consideration. It was the foundation of operational effectiveness. Determining whether units could execute assigned missions, German vehicles consistently failed this fundamental test throughout the war. American vehicles consistently passed it. The captured jeeps examined at Wehrmacht maintenance facilities had proven this beyond reasonable doubt by mid-1943. German mechanics and engineers understood American advantages, even as German commanders continued deploying Kübelwagens that required constant maintenance they could not provide. The Jeep did not win World War II through technical superiority in specifications. It won through engineering philosophy that prioritized what actually mattered under combat conditions. Simplicity, reliability, maintainability, sustainability. German engineers examining those captured vehicles understood this by 1943 based on their exhaustive testing. They documented their findings in detailed reports. They reached correct conclusions about American advantages, but understanding a problem and solving it are fundamentally different challenges. Germany's automotive industry lacked the capacity to retool production around reliability principles, while simultaneously fighting a losing war on multiple fronts against enemies with superior resources. American automotive industry had built reliability into its civilian manufacturing over decades of commercial competition and simply extended those mature principles to military production with remarkable success. The captured Jeep, that single Willys MB examined by Karl Richter in Tunisia, and thousands of similar vehicles examined by German mechanics across all theatres, told the entire story through mechanical simplicity and consistent performance. Every kilometre driven without failure was evidence that German vehicle design had taken fundamentally wrong path by prioritising specifications over sustainability. Every maintenance procedure completed by minimally trained soldiers was proof that American engineers had solved problems German designers didn't realise needed solving. Every repair accomplished with basic tools proved that industrial maturity and practical experience mattered more than theoretical performance calculations. The vehicle itself was unremarkable in many ways, just one of 600,000 produced. What it represented was devastating to German confidence, proof that Germany had already lost the industrial war even as fighting continued. Evidence that American productive capacity and engineering methodology could not be matched, regardless of German technical sophistication or tactical skill. March 1943. That morning in Tunisia, when Oberfeld webel Karl Richter opened the hood of a captured Jeep expecting complexity, the space he found instead, the accessible engine, the standard fasteners, the generous tolerances, the simple maintenance procedures, all of it revealed a truth German engineering had not wanted to face. American automotive excellence was not theoretical, it was practical, it was proven through decades of civilian industry. It was mature understanding applied to military requirements, and it was superior to everything Germany had developed for military vehicle applications. The recognition came too late to change the war's outcome, but it came definitively, documented in technical reports, confirmed by operational data, acknowledged by senior engineers and field mechanics alike. American simplicity had defeated German sophistication through the most fundamental metric possible. The vehicles simply worked when needed. That was the lesson German mechanics learned from captured Jeeps. That was the truth that transformed post-war German engineering. That was the legacy of the Willys MB and Ford GPW. Not power, not sophistication, not technical innovation, simply the profound understanding that reliability matters more than any other specification when equipment must function under real-world conditions. The Americans had known this from the beginning. German engineers learned it by examining captured vehicles and finally admitting what their mechanics had recognized immediately. Under combat conditions, simplicity works, sophistication fails. The vehicle that reaches the battlefield operational defeats the vehicle with superior specifications that breaks down en route. That was the truth Oberfeld webel Karl Richter discovered in March 1943 when he examined his first captured American Jeep. That was the lesson Wehrmacht mechanics documented over 2 years of comparing American and German vehicles under field conditions. That was the conclusion that German engineers finally, definitively accepted by war's end. American automotive industry had built something German precision engineering could not match. Not through superior technology, not through advanced materials, not through clever design, but through mature understanding of what sustained military operations actually required. simplicity that worked reliably under impossible conditions, engineering that prioritized sustainability over sophistication, vehicles that simply refused to stop working. The captured Jeep told that story completely. Every accessible component, every standard fastener, every generous tolerance, every simple procedure. All of it proved that American engineers understood something fundamental about military operations that German designers had never considered. Reliability defeats sophistication. Simplicity defeats complexity. Sustainability defeats optimization. German mechanics admitted they had never built simplicity like it, and they were right. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.